Hey there. Let's quickly talk about null terminators in C strings. So first off, what's a C string? It's basically just a character array. It's just an array of numbers, and the numbers will be interpreted as characters. And what's a null terminator? It's pretty easy. It's just a way to terminate the string so that a program can automatically determine where the string ends. In assembly, a lot of times we'll have, a string, like we'll say, oh gosh, I don't want to write this out right now. We'll say, my string, and we'll define it as an array of bytes, and then we'll say, hello or something, right? And then later, in order to tell the assembly program how long the string is, we'll use an extra symbol. This is not really an assembly video, but we'll say my string length is going to be, equal to, this is the ASCII assembly, by the way, in case you're wondering, some kind of special symbol, my string length. And then now we have defined the actual string and then the length of the string. But this is kind of annoying, right? We have to define an extra thing to say how long the string is. And then we have to, pass two different things that are, kind of the same name later on when we want to print a string. But that's not really the best way to do it. What if instead we just put a special symbol? I don't know, what should I put right now? Put a special zero. I'll just put like a question mark, and we'll say that the question mark is a special symbol. And then when we want to have part of our program print the string, we can just only give it the string, and it can scan the string. And as soon as it sees that special symbol, let's say the question mark for now, it'll know when to stop printing it or processing it or whatever. We could allow the program to scan in advance to compute the length and maybe store it somewhere so we can keep using it. We could allow the program to just continuously print out characters, maybe they're buffered or something, or processing characters, and then just stop when we get to the question mark. But the point is, it's a little bit less work for us to have a special symbol at the very end. Okay, so spoiler, the symbol is going to be a zero. I'll say that in a moment. But for now, let's look at a special table that is called ASCII. Well, the table's not called ASCII, but this is sort of like a scheme that was invented a long time ago. I forget what this stands for. It's like American Standard, maybe character something something. It's basically, for American purposes, a long time ago, we decided, you know what? I'd like to represent characters using 1 byte per character. So 8 bits, or a value that can go between 0 and 255. And we'll just start assigning these numbers to different characters. So you can see here on this ASCII table, this is kind of like an old thing. Let me turn on my little annotator. You can see on this table, well, the letter H is mapped to the number 72. So this was arbitrary at the time. Now it's a standard because everybody accepts, ASCII in certain parts of your programs. It's kind of a little out of date now because, in the modern era, it's a lot smarter for your programs to support a world of different characters, for all different languages, than only to support characters that are common in English. And even here, there's probably some stuff missing that English users would probably want to add, like certain accents and symbols and things like that. So, the letter O, lowercase o, it's 111. The letter O uppercase is 79. So we've got, a basic idea of mapping. So for the purposes of this example, I'm just going to assume we're using ASCII to make things easier. Okay, so that's an ASCII table. I guess I should say that the modern scheme that we usually use is called UTF. Let me just write that down on a notepad right now. So we've got UTF right now. It's just a different standard, a different mapping, but the same idea. With ASCII, we only had 1 byte. With UTF, we have a wide variety of choices. We can do UTF-8, which basically also means 1 byte. It closely maps to ASCII. I think all or almost all the characters will map to ASCII. And then we have UTF-16, which means 2 bytes or 16 bits. And then we have UTF-32, which is basically 4 bytes or 32 bits. As far as I understand, I haven't checked this in a while, UTF-32 should be able to handle all the characters that all the languages of the world commonly use. Just to double check, if you take 2 to the something power, where the power, let's say y, 2 to the y, where y is the number of bits in question, then you can get an idea for the number of combinations that you can represent. So 2 to the 32nd power, that's about 4 billion. I should have known that off the top of my head. That's about 4 billion possible combinations. So I don't know. I think, in my opinion, probably 32 is enough for all symbols in the world, for all languages in the world. I'm not sure. If not, then we would probably want to use UTF-64 if that exists, which definitely would cover all symbols in the world. But that's really not the point of this video. I just wanted to mention it because if you're writing an application on your own, you want to start your own business, or you're working for someone, you probably almost certainly do not want to use ASCII. You probably want your database and your program to be able to use UTF-16 or 32 because you want to be able to support international users, and that's not going to work. I had a website a long time ago that I wrote. The database was in, it was like Latin 8 or some scheme in the database where it was basically ASCII, just 8 bits per character. And I started attracting international users, and none of them could type characters in their native language, and they were kind of disappointed, and I lost a lot of business until I realized, oh, I should upgrade my database and my program to support UTF. But anyway, the point of this video is not international character support. The point of this video is, what is a null terminator and how do you use it in a C string? So I'm going to get back on track here. All right, so imagine that you want to let's say, represent the string hello. Okay, so we got hello. This would basically be an array of characters, or an array of, in ASCII, 1-byte characters. So I'll put like a number here and a number here, and there'll be 5 numbers. What numbers are they? Well, if we're using ASCII, then we should map these using the ASCII table. So again, in the ASCII table here, what is capital H? Where's capital H? I can't even see it. Capital H, that's the number 72. And then the lowercase e, that's going to be the number 101. So I'll just maybe do like an arrow here, the number 101. And then the capital H is going to be the number 72. And then we got 2 L's, lowercase, so that's going to be this right here. And that's going to be the number 108. And then lowercase o, that's going to be the number 111. So basically, you just go through the characters you want to represent and map them using the ASCII table, or hopefully an actual lookup table inside your program. And then you can do the same thing backwards. What does 72 mean? It means H. So I'm going to erase this for now, and I'm going to go back to my little notepad here, and I'm just going to fill out the numbers. So the first is going to be 72. Oh, actually, before I fill these out, hang on. Let me just show you that this is basically what we're trying to translate here. So we got like an uppercase H. In many programming languages, definitely C++, which is the one I'm thinking of, we would use double quotes for an actual long string, like a proper string, a literal string, or like an STD string or something. And we would use an array of single quoted characters to say, this is one character that maps to 1 or more bytes. In this case, 1 byte. So I'm going to say HELLO, and put them all in single quotes, and then we'll just sort of like translate the numbers here. So we said the H was 72 because it was capital, it was like a lower number, and then the E is going to be 101, and then the L is 108. We'll do 2 of those, 108, and then the O was a 111, 111. So you can imagine somewhere in an array of data in the computer, there's the number 72, 101, 108, whatever. And even further, thinking about it a little more deeply, the number 72 is not actually in the machine. It's really a sequence of 1s and 0s, right? So just imagine that inside the machine, there's just a ton of 1s and 0s. For this particular sequence, 5 times 8, which would be the number of, 8 is like the number of bits per byte, since we're doing 1-byte characters. What is that, 40? Let me just double check here. I want to make sure I'm saying things that are somewhat correct. We'll do 8 times 5. Whoops, I think I screwed something up. 8 times 5, 40. Yeah, okay, so you can imagine 40 1s and 0s just inside the machine. Anyway, so we talked about before not wanting to specify the length of a string. So we'll just place a special marker. Instead of a question mark, we'll use the number 0. So I'm going to put a 0 at the end of this array. Let me show you why. I forgot if I actually pointed this out or not. I'll just do this to be sure. Somewhere on this, you can see that the number 0 in decimal, or 0 in hex, or 0 in octal, you're welcome. You know how to do those other systems, is just considered null. So it's sort of a control code, or it's not necessarily a symbol, it's more of a control code. We'll say that when we're sweeping through our string, if we see the number 72, that means H, capital H, but if we see the number 0, that means null. And in the scheme that we're going to use, we will say that null terminates the string. That's why we call it a null terminator. So null terminators are basically just zeros that terminate the string. I could put null here inside of the character representation just to kind of show you that it's equivalent. But when we're in C++ and some other languages, and we want to do single quoted characters, we can usually use an escape sequence, which is just basically /0. This is not a video about escape sequences, but imagine that every time there is a slash, a forward slash, and then one character after that, then the character will be interpreted 0. For example, if we just put 0 by itself, then that actually would be the ASCII code for 0, or just the character code for 0. In this particular case, 0 is, where the heck is the 0? Can't even find it. Oh, there it is, right there. That's like, so the character 0 is represented by the number 48, but that's not what we actually want. We want the actual number 0 because we're trying to get a null terminator. So anyway, we couldn't just put a regular 0 in there because that would be interpreted as 48. Instead, we put a slash, which tells the computer that the thing that follows is a control character, so that will be interpreted as actually a 0 or null terminator. So now that we know how to put a null terminator in an array of characters, and we know what it's going to look like if we're just talking about numbers, we now know that if you have a program that has, let's say, a for loop, and it's kind of like going through, do all the characters, if it's going through every single character one by one and doing something to them, printing them, modifying, adding them to an algorithm, whatever. This for loop, or actually this should probably be a while loop since for loops are kind of limited, and the while loop will know when to break, because as soon as it sees a character that is actually just the number 0, it'll say, oh, I found the null terminator. I will now ignore this and break the loop. I won't do anything with this character because the null is a terminator. It's not part of the string. What else? Actually, I think that's pretty much it. If you're in assembly, I'm just going to go back to YASM assembly for a second because I like to talk about that lately. Imagine we have like a string called myString, and we say it's a sequence of bytes, and I say hello. This is how you would do this in x84 64 YASM assembly on Ubuntu or just Linux. Then this string right here is just a string with no null terminator. You want to add a null terminator to the end of it so that you can write a better function that would scan your string and print it without knowing in advance how long it was. Then you just do a (0) at the end. And now you can easily write a function to scan or read or process your strings, because this is really what's happening under the hood. It's just like a sequence of characters, and then it ends with the 0. And there you go. That's the basics of C strings with null terminators. Thank you for watching this video. I hope you had fun and learned a little bit of stuff. I'll see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community, so we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. Sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness, which is coming for us all.